Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEX topic, proving the Pythagorean theorem using similar triangles. So this one is a little bit interesting in the fact that it's pretty similar every time you approach it. It's not like you're going to get a bunch of different types of problems. Alright, so let's see what we're trying to do here though. We want to, they told us this, that triangle ACD is similar to ABC, which is the big one, which is also similar to CBD. So all of these triangles are similar. So using that, we're going to fill in some of this information. Complete the proportions. So C over A. So be careful as we're going through here. It's really easy to mix things up. So notice these are lowercase letters, so these are side lengths as opposed to our A, B, C, D, which are capital letters. Those are our points. So there's a lot of stuff going on. So right now we have C over A side lengths, so that's the hypotenuse of the largest one and the hypotenuse of the smallest one, C and A. So I'm going to see how these relate to each other. So we have that there, and then A, C over A, so then A of the... Actually, let's change this a little bit. That'll work, but let's look at C and A in terms of the same triangle. It might be a little bit easier. So we have the hypotenuse and the small side of the biggest triangle, and then we have the hypotenuse, so we want the small side, so hypotenuse small equals hypotenuse small. We want those to line up. So the hypotenuse of the smallest triangle over the small side of the smallest triangle, which is going to be x here. Okay, and here I have hypotenuse over long leg equals here, which is hypotenuse over long leg, which is going to be this one with y. Okay. So we're going to find cross products here. So using this one, a times a is a squared. C times x, b times b is b squared, and c times y. Alrighty. So we're just going to keep working along here. We're basically adding our two things together. So a squared plus b squared is going to be, so since these are equal, I can use that and just plug these in. So it's cx and cy. Just taking those sides multiplied together. Factor out that, we end up with x plus y. If we look here, x here and y here, if we add those together, that gives us our whole thing here, which is c. So that's a segment addition, x and y. The two parts add together equal the whole thing. So if I plug that in, or do a substitution, if you will, take that xy out, I can plug in my new one. So that's c times c, which is c squared. And that is your Pythagorean theorem. So that's how we prove it algebraically, running all the way through, just using a bunch of similar triangles.